Well, good evening, everyone. My name is John Bankhoff here with my colleague Mike D'Angelo,
Hi.
and we're very excited about being able to get this final Skywarn training of 2020 started. We're going to wait a few minutes just to give everybody a chance to get logged in and situated, but feel free to send us a little message in the chat saying, hey, just making sure everybody can see everything okay, and we'll get this thing rolling here in just a few minutes.
Just to let you know, we're not the number 9 hitters. If you want to, talk about baseball, we're the cleanup hitters.
You got the dream team here tonight, everybody.
He's the good-looking one. I got the brains
and the wisdom too. The shinier the head, the more wisdom there is.
Should I go get a hat? Should I go get a hat to, keep the shine down?
That's funny. Let's see. I'm assuming everybody can hear us okay. I'm not seeing anything in the chat room, but it's probably all right. As you can see, Mike is at the office with the Weather Service State College logo behind him. I am at my house, going to be working a midnight shift tonight. With the current pandemic limitations, basically, we're trying to minimize the number of people at our office. So I'm in my office, in my loft at my house, and Mike is from the office. So we're also doing this thing virtually.
I have a couple of college-age daughters who have some finals tonight. And just, with all of us trying to be online at the same time and doing webinars and all that kind of stuff, that might be a bad idea. But I really don't have a computer that would be in a quiet place in the house to, drag around with me. And I thought this might be better.
Yeah. My wife just went to the grocery store, so I have the house to myself now for a little while.
Rarely make trips out now. I'm saving on gas, even though gas is dirt. We did go down and get Sarah. We went down and got her on Friday. My oldest daughter, Sarah, graduated from Alabama Huntsville on Thursday. So we went and got her last Friday. She's home. She's waiting to start her new job, but she's also going to be working for the government. But she's, and it's a very strange time right now for everybody, but especially for government folks. We're trying to figure out how our new hires will come along. We've hired a new woman from Penn State recently, Rachel. She'll be here, I guess, starting next week, John?
Yep, she starts Monday. Yep.
So, she'll be starting soon, but there's, a lot of the time she's not going to be in the office. She'll be learning remotely and, getting all her things done, outside the office as much as possible. But she's, going to be starting soon, and I'm hoping that my daughter will be out there soon as well. No, she's not a meteorologist. Not everybody's perfect.
Yeah. Well, folks, it's just after 6 o'clock. I guess we can go ahead and get started with introductions. I still see some people logging on. We got about 29 to start. I think about 59 are registered. So we'll just kind of talk slow as we start the introduction. But as I mentioned just a little bit ago, I'm John Bankhoff. Started at the National Weather Service actually about 2 years ago, 1 week from now. It was May 14th of 2018. And it has been a blast ever since. Man, 2018 was a crazy busy year. Those of you that have lived in Pennsylvania for a little while remember how it didn't stop raining like nonstop. Also experienced the winter that wasn't of 2019 and 2020. Probably still a sore spot for some people, but if you guys like snow, there might still be a chance tomorrow night into Saturday. It looks like. I don't know if that's really a good thing. Snow in May doesn't really make it high on my list of things I want to experience. But I went to the Ohio State University for undergrad. Got a degree in meteorology. Boo! I grew up in Columbus, and then I came out to Penn State for grad school back in 2016. And then got hired on at the Weather Service. It's been a blast. This is our, I believe, our 4th virtual Skywarn talk this year. Generally, we try to do these in person in the various counties across our area, but because of COVID-19, we were forced to make some different arrangements. And in fact, I think it's worked out pretty nicely. We don't have quite the limitation or the location limitations that we have with other things. But that's me, excited to chat with you guys tonight. We'll talk a little bit more about how the day's going to go, but I'm going to throw it to my left to Mike D'Angelo so he can introduce himself.
My name's Mike, as John had said. I've been working for the Weather Service a little bit longer than John. Oh, goodness, just over 25 years now, and got a nice pin for that. But I really love talking to folks about the Weather Service and telling them the great things that we do. You know, I think our work is very important, and I love getting messages out to you so that you can plan your days and stay safe. John, I think, did not mention that he just got married. So if everyone says a great congratulations to John. John just got married this past weekend, and he and his new wife are enjoying their first couple of days together.
Yeah, really though.
Didn't really go anywhere for his honeymoon. That kind of thing has been quelled for now, but yeah, they've got plans. I have a growing family. Now they're, well, as in getting older, they're now, the youngest is now a junior in high school. And like I said before, my oldest daughter's just graduated from college, and I have two daughters in between there. And they're going through their finals right now, all online and remotely, I guess is the best term for that. Without further ado, let's get started, John.
Yeah, that sounds good to me. So hopefully you're in the right spot. This is Skywarn Training 2020 for the National Weather Service in State College, Pennsylvania. Just to give you a little bit of an overview of what we're going to be looking at tonight. Let me see if I can click through. Yep. So first off, attendee engagement. We're getting used to this GoToWebinar capability, but there's a few ways that you can interact with us. You can ask us a question. We encourage you to do that throughout the presentation. We may not get to it during the presentation, but certainly at the end, we'll try to answer as many questions as you have. You can enter the question in the GoToWebinar window on your screen. That's under the chat section. You can also raise your hand using the raise your hand button. You should be able to see that as well. If you do have questions, again, we'll probably wait to do that until the end, just out of the interest of time. But please raise your hand there. And then finally, we'll talk about more of this later, but there are 3 handouts included in this webinar that we encourage you to download. The first is a spotter reporting guidelines sheet. That's going to be sort of your cheat sheet for our presentation tonight, what we want to know from you, how to communicate with us, etc. Then there's the ham radio operator repeaters map. So for those of you that are ham radio operators, you can figure out how to communicate with us. And then finally, a pretty slick document that is a weather spotter field guide. It has a lot more information beyond what we're going to cover tonight. You can use as sort of a textbook or reference document moving forward. So we encourage you guys to communicate with us again through the chat, through raising your hand at the end. We'll try to answer questions, maybe even at the end of some of these sections. So yeah, let's go ahead and click forward. So overview of today, we expect this thing to probably last about an hour and a half or so. We'll see, depending on how long-winded or fast we talk. We'll do an overview of the National Weather Service, who we are. We'll talk about the Skywarn program, why we're here, what we're about, what our goal is with this particular program. And then we're going to get to the stuff that we weather weenies really enjoy, talking about the weather, the things that we experience sometimes on a monthly or even a daily basis, summertime severe weather, so tornadoes and thunderstorms. Then we'll talk about some flooding, a pretty common thing here in Pennsylvania. And then our wintertime events for the snow lovers. We'll finish up with some reporting guidelines, and then we'll talk about the sign up, basically how you become an official storm spotter. So that's an overview. And now I'm going to go ahead and pass it over to Mike to continue on.
Thanks, John. I'm going to go over a little bit the boring stuff about the National Weather Service. Some of you may know this stuff, but there's some interesting nuggets in here too. The National Weather Service is part of the National Oceanic and Atmospheric Administration. We fall under the Department of Commerce. A lot of people wonder why that might be. Well, weather has everything to do with commerce, movement of goods and materials, how the economy runs. Some of the biggest, I guess, interruptions to our commerce and economy in our country are due to weather events. Then I guess, some of the bigger other things that I can think of is the aftermath of September 2001, and then certainly the current COVID epidemic. But most large things that impact our country over a wide area are weather events, hurricanes, flooding, severe weather outbreaks. Our primary mission at the National Weather Service is to provide forecasts and warnings to keep you safe, so that you can protect your property, but more importantly, so you could stay safe yourselves and keep your family safe. The Weather Service is made up of mostly the local offices like ours. We do the forecasting every single day. We make the warnings that come out to you. But there's some larger organizations, the national centers, Aviation Weather Center, Climate Prediction Center, Environmental Modeling Center, Central Operations, National Hurricane Center, Ocean Prediction Center, the Storm Prediction Center, Space Weather Prediction Center, and the Weather Prediction Center. All these are in different locations in the country, and they tend to deal with their specific areas of expertise. The Climate Prediction Center knows more about the forecast for the next 6 to 900 days than we do here at our local office. We concentrate on our little chunk of the world. We'll see in a minute how big our chunk of the world is versus theirs. The National Hurricane Center is a place that I'm sure all of you have heard about, and the Storm Prediction Center, also something that you probably heard about. They're out in Norman, Oklahoma. The Hurricane Center's down in Miami, Florida. So out of these local offices, there's 122 weather forecast offices. 5 of those offices take chunks of Pennsylvania. Our chunk is entirely Pennsylvania. The rest of them have parts of other states as well. 13 river forecast centers also serve nation. 2 of them splitting up Pennsylvania down the Allegheny Divide. All of the water to the west of the Allegheny Divide runs either into the Great Lakes or down the Ohio River, and the water to the east flows into the Atlantic Ocean eventually, but generally into the Potomac, the Susquehanna, and some of the larger streams in the eastern part of the county state, like the Delaware River as well. There are some regional offices, so they're like, I guess, the overseers of the local weather forecast offices, and overseers of everyone, the National Weather Service headquarters, which is down in Silver Spring, Maryland. Now, they're off in a different place from some of those national centers that are also in DC. Some of those places also in DC are the Environmental Modeling Center, the Ocean Prediction Center, the Central Operations, and the other places, Space Weather Prediction Center. They're out in Boulder, Colorado. The Aviation Weather Center, they're out in Kansas City. So where are those local offices, you ask me? Well, ours covers, like I said, a good portion of Pennsylvania, about the middle third to maybe even a little bit more than the third of the state. The Binghamton, New York office, there we go. The Pittsburgh office handles the southwestern and western portions of the state. The Philadelphia office, which is in Mount Holly, New Jersey, covers basically the areas that think they're in Philadelphia. The Binghamton, New York office handles the Endless Mountains and the Poconos, and Cleveland office handles the forecasts and warnings for the Erie Lakeshore and down into Crawford County as well, mainly because of the climate there. Things are very much similar there than to Erie Lakeshore, Erie Inland County. They're very much similar to where Cleveland is, and their radar's closer there than ours is to Erie itself. So the local office, we have about 25 people. We're short a couple of people right now, but we're working on that. Rachel will get here and we'll be so much happier to have a little bit more help. About 14 forecasters usually, 1 boss, she's the meteorologist in charge, Barb Watson. We have 5 electronic technicians and 6 folks we'll call specialists because they have a specific area that they concentrate their efforts on. One would be for all the observations across the area, organizing them. Hydrology, which is river stuff and water stuff. research and training, outreach, which John and I are kind of handling right now, information technology, because we, as you maybe can see by the picture there of our former colleague, Joe, he's surrounded by computer monitors, and we have a lot of information technology that we have to keep running all the time. In fact, two of our folks were in here today fixing some problems, even though that we've been trying to keep the office as bare as possible of people, but they had to be here to do the work that they needed to do. And we have our administrative assistant who keeps everything running. We're here 24/7, 365. And we do that in a rotating shift. So there's 3 shifts a day, but we break it up so that there's one forecaster typically working on the near-term forecast, the next 24 to 36 hours. And one of my jobs as the senior forecaster, the lead forecaster, is I parse up the work to people. I say, well, here, you can work on this. Would you like to work on that? Usually I'm not too heavy-handed, am I, John?
Not too bad.
All right. And then we have a person working a little bit farther out then, days 2 through 7. We only handle the specific forecast out to day 7. Beyond that, I mentioned that's the Climate Prediction Center who takes care of that stuff. So the long-term person doing more model diagnostics, I think, than the short-term forecaster. But the short-term forecaster has a couple of different things going on. They're juggling watching the radar and updating the forecast, like the general forecast that you'd think of, but we also do the specific aviation forecast for 7 airports across our area. We also worry about staffing issues and who's coming in to fix the computers, things like that. We also have a public service desk for 2 of the 3 shifts throughout the day, and one of those right now, because of the epidemic, is at home, working remotely. But is able to still do a lot of stuff for us. Obviously can't answer the phone here at the office, but we can work on that too. Technology out there available for us, but this is the government. Sometimes things run kind of slowly that way. So what happens when it gets busy? When it gets busy, we start calling in more people. More people is the best way to handle things. You can get really tired really quickly, especially in a severe weather situation where there's all kinds of stuff going on. You have to call people in, and then we divvy up jobs between them, and everybody kind of has to know their role, because you stay on track, do the things that you need to do. You can help out by pointing things out to other people who are doing the different job, but generally we have a storm coordinator who helps everyone stay on track. The short-term forecaster continues doing what they were doing. The long-term forecaster continues what they were doing. Sometimes if we don't have an ideal setup like this many people as we have in the graphic here, that may be the same person. They may end up doing all 7 days of the forecast. But the important thing is getting those warnings out that we need to do immediately to help save lives. The public service desk is also absorbing a lot of information, gathering reports from internet sources, but also, taking those phone calls, talking to news reporters who may be calling. We do have maybe a person sometimes who would be dedicated to doing the social media aspects of our job, interacting with the public that way. We have a decision support meteorologist who's, trying to make sure that our weather message is getting out to the public. Our message isn't just bits and bytes going through computers, but our message is also something that has to be visual, has to be audible, has to be sometimes in your face to get people's attention. And they may be working with some of the local media folks as well, trying to make sure that they're getting the message out, and they do a wonderful job of relaying our forecasts and warnings. And then there's the radar and warning team, and like it says, these folks are there, doing nothing but watching the radar, making the warning decisions, putting out the warnings, making sure they get places, and then they let the rest of the team handle the minutia, I guess is the way to term that. Some of the stuff we use. What do we use to forecast the weather? How do we monitor the weather? Well, we have the Doppler radar. Everybody knows that. They've heard Doppler radar for 20 years now. If you've ever wondered, if you don't know who Dr. Doppler was, he was an Austrian physicist who figured out that I guess the best Best way to put this is, if the train's coming towards you and then it blows by you, it makes it different. There's a different pitch to the sound of the train as it's coming towards you, and then as it's going by you. There's that whoosh, the change in the pitch. That's the Doppler effect, and that's what our radar is doing right then, is it's telling us which way that precipitation is moving on the radar. It can tell us, is it moving toward the radar? Is it moving away? And we've got some new technology that helps us out even further. It can tell us the size, the shape of the droplets or the hailstones or the snow. And that can, give us a whole bunch more information to help us make better warning decisions. We have satellites that are a very expensive thing to do, and put them up in the air, run them constantly. That's a good portion of the budget of NOAA every year, is developing satellites and launching them into space. We do nothing but work on computers. Our computers are our lifeblood, and that's to get the remote sensing equipment information from those sites that may be out in the fields or in airports typically, where they're sending us information back on how thick the clouds are, temperature, wind direction, speed, if the precipitation is snow or rain. But it's all through the computers, all through the wires, that information needs to get to us, and then we use those things to make our forecasts. So I'll let John talk about the Skywarn program now and why you're here.
All right, so the Skywarn program, it's a group of trained volunteers who report hazardous weather. And the reason we want to do this is basically we have all this equipment. We have the radar, we have the satellite, we have these automated surface observation systems that are at the airports, but we don't always know if that's representative or not. The radar can tell us, is it raining? It can give us an estimate of how much, but what we really rely on is ground truth. We want it to be in real time as well. And so you provide ground truth. The other thing that it does is adds credibility to our products. For example, when a severe thunderstorm warning is issued, and we say that radar has indicated, strong damaging winds, or radar indicated 1-inch hail. Okay, that's going to be a little bit different than when we can put in our warning, a trained spotter reports ping pong ball sized hail at XYZ location. That provides credibility to our products and help us get the word out a little bit better. So you are invaluable, and we really appreciate you being here. You literally act as thousands of eyes and ears out in the field, and it's super helpful for us to do our jobs much better than we could without you. Currently, NWS State College has over 3,000 trained spotters. Actually, after this influx of spring registrations, we're pushing over 4,000, heading towards 5,000. So it's a very well-developed group of people, about 10,000 spotters and counting statewide, and nationally over 300,000. So there's a pretty good conglomerate of people, and we're excited that you're a part of this. One other thing to note while we're at it here, if you ever move, your new local office will also accept your spotter certification. So just let us know. We can certainly pass that information along, and we work pretty closely with other weather service offices locally, but also across the country. And so don't worry about it if you have to move. We do just ask, though, that wherever you are, you report the weather to that particular office. If you're in Nebraska, you can communicate with State College what's happening, but it's easier if you just reach out to the Nebraska office to get that information a little more quickly. So today we're going to be talking about the basics of observing weather. And what we want to focus on is accurate reporting. We want to equip you with the information you need to be able to tell us what we're looking for. We're going to look at some key definitions and look at some different weather elements so that it can be educational, but also informative, and that we want to make sure that our communication stream with you guys is effective. We can get information to you, you guys can get information to us. And at the end of that, you're going to be a trained Skywarn spotter. So we're really excited about that. For those of you that are here for the first time, welcome. For those of you that are coming back to us and have already done a spotter talk before, thanks for coming back. We appreciate your excitement and enthusiasm to assist us in this process.
And I really appreciate those folks. We'd really appreciate your input on how this went versus seeing somebody in person. This is something that not only may we have to do for the foreseeable future, but it may be an easier way to do this every year in more than just a few locations.
Yeah. No.
So let me talk about NWS products. What does the NWS produce? Well, we like to tell people things in advance. So what we try and do is get out there before something's going to happen, and we make just the forecast, general forecast. You may hear that, my goodness, Tuesday is going to be rainy and whatever. Well, that's our forecast. Then as things get nearer and maybe there's going to be some heavy rain, we may put out a statement that is an outlook saying that flooding is possible. There's going to be some heavy rain on Tuesday and flooding is possible. Mind you, Tuesday is just an example here. Then as time gets closer and maybe we get more confidence in our forecast, we would issue a flood watch. And then as we get closer and closer, and maybe as it's right on top of us too, we would go to warnings and say, this location is going to have flooding. Please be safe. So the difference between them, well, an outlook means that something's possible. In general, we have a 30 to 50% chance of it occurring. Again, it's something that's out in the future, and we have confidence enough to start talking about it, that it might be a big enough event that we would want to start talking to people about it. But we're just not there yet. We're just not sure what's going to be leading us in a direction either one way or the other. Is it going to be dry? Is it going to be wet? The watch conditions are favorable for a given weather event, and what that means is we're still not entirely certain, but we're more certain than not that there's going to be some kind of bad weather happening. So somewhere in the confidence range, which is a subjective number, 50 to 79%. When we hit 80%, fairly certain something bad is going to happen. So then we go from an outlook or watch, we jump into warnings. And now for the different kinds of weather that there are, we can really only be certain of severe weather, severe thunderstorm weather, tornadoes, flash flooding. We can really only be that certain about it a few hours or even minutes ahead of time, where for snow events, for even flooding rains, we may be more confident 12, 24, 36 hours in advance of when things would start up. But the warnings also paired with a thing called an advisory. We'll talk about advisories in a second. So what about that outlook? Well, our products aren't just text. Our products are also pictures. There a bunch of information on our website and links to places like the Storm Prediction Center. This graphic here, you can readily tell by just glancing at it where the bad weather will be on that day. And those outlooks from the Storm Prediction Center, like this here, that covers a specific day, 24 hours out, 24 to 48 hours out, 48 to 64 hours out. But our products that would come from our local office just have some, I guess, typos in it. I didn't see that typo in there, John. Did you see that? Our hazardous weather outlook would just start to mention that we might have some trouble too, and it would try and make that calling it out, but not jumping up and down on it. For the severe weather outlooks that come from the Storm Prediction Center, there's now 5 levels to it. There's just a regular old thunderstorm. In this case, in this graphic, it's going to be the very light green color. There will be thunderstorms around. Inside that is maybe how much worse the thunderstorms could be. The marginal risk of severe weather means that there could be a couple severe thunderstorms around in that area. Slight risk means those thunderstorms that do occur have a better chance of being damaging storms, and stronger storms as well. An enhanced risk means that there's even a greater percentage of those storms which are going to become severe. And the moderate risk and the high risk, we rarely see those in Pennsylvania, but those are the really high impact days, the days when people are going to be losing their lives. The work of the National Weather Service, we sit behind our computers, we make our warnings, but we really need help to get the warnings out and have people hear them, because every year there's people lose their lives, and that's what we're here to do, is to make them aware so they can keep themselves as safe as possible. So that, a watch can come out in, that graphical form or the text form. The watch, again, is after the outlook phase. It's more certain that things are going to happen, but it's a broader area. It's not narrowly defined like we're going to do with our severe thunderstorm and tornado warnings. This is something that'll, catch an entire, 3-4 states at a time, because all those areas would have the chance of a severe weather happening near them. They don't have that same chance because the weather conditions are very similar throughout that entire area. For a warning, we try and get smaller and smaller, so we're not crying wolf to everyone. I hear, lots of criticism. Look, I've been doing this more than 25 years. I hear lots of criticism that, oh, we get so many warnings and we don't get damage. That's because damage only happens in a very tiny little part of a storm. A storm that will do widespread damage over, hundreds of miles, we'll talk about in just a second, those are very, very rare. Tornadoes and even severe thunderstorm winds are very narrow, very tiny little portions of a storm. But the warning, we try and get out as soon as possible before the event, before something would happen. So we're looking at radar, we're looking at the satellite pictures to help us. We're looking at the local observations. Well, how hot is it? How much moisture is there? Which way are the winds coming from? And we're making those warning decisions, in the heat of battle, minute by minute. So what are we talking when we're talking about severe summertime weather? Well, I guess I could let John talk about this a little bit. Is what we mean by severe weather.
Yeah, so severe weather has a specific definition. So when we issue a severe thunderstorm warning, we're expecting one of these things, or at least one of these things, to be occurring. We want a measured wind gust of 58 miles an hour or higher. We generally think that it's fairly difficult to estimate wind speed. So realistically, a proxy that we use for damaging winds is going to be storms producing significant structural damage. So maybe there's a swath of trees that are down. Maybe there's shingles ripped off of a roof. Maybe there's siding that's come off of a house. Those are some of the different things that we use to designate or indicate that a severe thunderstorm is occurring. Another thing is hail. Many of you guys have probably seen or experienced hail before. Severe hail is defined as being 1 inch or greater. It's pretty rare to get severe hail here in central Pennsylvania, down towards southeast at Harrisburg, York, Lancaster, etc. Those are places that it's a little more common. But generally speaking, because it's so warm, a lot of times maybe there is a 1 inch hail in the storm, but it'll melt a little bit by the time it gets down. But again, 1 inch hail or greater in diameter is considered severe. And then a tornado. Ultimately, we're going to hopefully have a tornado warning on that, so that'll be a little bit different. But any thunderstorm that produces a tornado is also considered severe. Now, what's not severe? We get a lot of comments often about, man, it's lightning like crazy out there. We do not necessarily issue any products for lightning. And the reason for that is every single thunderstorm by definition has lightning. And so if we were issuing a severe thunderstorm warning, for example, on every single storm that had lightning, we would be issuing a whole heck of a lot. And we do work with particular outdoor events. So we work with Lycoming County for the Little League World Series. We work with Huntington County for Creation Fest. And we do provide specific notice for areas that are vulnerable, that are outside, that could experience some hazards from lightning. But a severe thunderstorm a storm producing lightning is not necessarily severe. The other thing is when you get a large accumulation of small hail. Okay, so 3 inches of pea-sized hail accumulation. You guys have probably seen videos, not from Pennsylvania necessarily, but other parts of the country where people are literally plowing hail. That's not considered severe either. That's fascinating, that's cool, that's crazy, but again, you need hail 1 inch in diameter or greater to be considered severe.
And that 1 inch is because it's actually poking holes in things. It's going to be doing damage to car roofs and to even, house roofs. Absolutely,
yeah. So what about sub-severe storms? So even if we're not issuing a severe thunderstorm warning, we still have a mechanism to communicate some impacts that are impending, and that's through a special weather statement. Now, you're not going to get pinged on these in your phone unless you have an app that is set up to receive them. Many of you may have that set up. But basically what we want to do for those is if there's a storm that's sub-severe but still going to be fairly significant, we're going to put out a special weather statement. Generally winds 30 to 54 miles an hour, again, just below sort of that threshold. P to nickel size hail. If there is hail, we're generally going to try to have a special weather statement out on that. And again, these aren't going to trigger your phone apps. The goal is not to startle you. It's more of just a, hey, heads up. And realistically speaking, you're probably going to see the sky getting dark and maybe hearing some rumbles of thunder in the distance anyway. But this is just another tool that we have. Now, one thing Mike mentioned earlier was advisories. So this is another tool that we have in our toolbox. So in winter situations, a significant storm is going to be a winter storm warning. And we'll talk about this a little bit more. Something that's not quite as significant is going to be covered by an advisory. Now, one of the things to note, an advisory is not any less likely than a warning event. So if we issue an advisory, we still have about as much confidence that it's going to happen. The difference is it's just not going to be as much snowfall. So an advisory is not a downgrade. An advisory is not we're less confident. An advisory is not that we're kind of waffling on our forecast. It just means we're not forecasting as much snow. But again, that's another tool we have. Severe thunderstorm warning, special weather statement. Think about it the same as a winter storm warning and a winter weather advisory. Now we'll go ahead and watch this video. I'm not sure if you're going to be able to have any volume on it, perhaps not. But what you're going to see here is a video, somebody sitting on their porch as a storm comes through. And obviously we don't have an ability to necessarily interact right now, but as we're going through this, I want you to just start thinking about, okay, at what point do we reach severe criteria? Okay. Some of you guys might be thinking, yeah, that's it, that's severe. Some small branches starting to come down. I think at the National Weather Service, this would probably be justification for us now to be issuing a special weather statement because there's some pretty good winds. Some small branches are not necessarily super strong and not enough to really reach severe criteria. Small branches can come off with a lot lower winds, but certainly this is going to wake you up. You're going to want to not be outside as this thing comes through. So again, we're probably looking at special weather statement territory here. We would want you to kind of call and let us know, hey, I got some branches down. We would want to know what's happening. But as this thing moves through, and I might be giving a little bit away, you could probably imagine we wouldn't show this video unless things started going sideways fast.
Like that.
Just like that, pun intended. Mike is a big fan of dad jokes. I am also a big fan of dad jokes. So here we are. Things went sideways. The tree has now broken off. At that point, you know, it's one tree, so perhaps it's a little hard to tell exactly how strong the winds were at that point. But that's a fairly significant storm for that tree to literally break off. We're probably going to want to have a severe thunderstorm warning on that, especially given that the storm was somewhat intensifying as it moved through the area. So just a real life example there of kind of our thought process and what we want you to communicate with us as you're going. Disclaimer, not a good idea to be out on your porch as a storm is coming through. I can't tell if this person was inside or if they were outside, but just use common sense. We appreciate the reports, but we want you to do it very safely.
For all you weather weenies out there, you know, the meteorologists, we tended to do that. You know, that was one of the reasons I got interested in weather, was because I did on my grandmother's porch, and I'd watch, you know, storms go through and the weather change. I just thought that was fascinating.
So fun. All right, so many of you probably came here for this part of the talk. We're going to actually dive in and talk about some significant severe summertime weather. And May is generally the time when we start getting into sort of a more active period. Obviously, it's been pretty chilly lately, so not a whole lot of juice to be able to fire off thunderstorms. Let's go ahead and dive in and chat and just hopefully educate and equip you guys with what you need to be able to help us as we move into severe weather season here in Pennsylvania. So what we're going to first talk about are damaging wind types. And the idea here is that you're going to be able to help us in communicating various types of damage that we want to see, and also potentially assist us in kind of queuing us off on what may have happened. Now, we're ultimately going to be the ones that make that call. We're going to maybe go do a damage survey, but you can assist us. We're going to talk a little bit about that. So the three types of damaging winds we're going to talk about are straight line, downburst, and tornadoes. So let's go ahead and dive in. First, straight line winds. Most common type of wind damage we see here in Pennsylvania and they're often a result of a squall line. Many of you guys have probably heard the term squall line before. That's just basically a line of storms that has much longer horizontal extent than sort of front to back extent. There's a radar picture here on the bottom right that you can see. A line of storms that's racing off to the south and east. Generally speaking, going to be fairly strong winds out ahead of the line even, and that's going to kind of mow things down. These winds result from a combination of both the forward movement of the storm, and then you get transport of strong winds aloft all the way that mix down to the surface, and that combination can result in damaging winds. Now, again, just as a note, from a safety standpoint, winds are likely going to start before the rain begins, so don't wait for the rain to start to get the heck out of Dodge. It can be a fairly dangerous thing. We have a schematic here showing, so say about 5,000 feet above the surface. Okay, pretty representative height. So you have 35-mile-an-hour winds. This is not uncommon for a fairly dynamic summertime system. And what's going to happen is you get rain-cooled air. Okay, so rain forms, you get basically condensation occurs, you get evaporational cooling, and that air mass is going to become colder and more dense, and it's going to start sinking down to the surface. As that sinks, it's going to carry with it some of those winds, and that's going to result in surface wind gusts of up to 65 miles an hour. So forward propagation, along with winds aloft that get mixed down at the surface, and we get severe thunderstorm winds. Now, these are generally going to happen, the damage from this is going to generally happen in a single direction, basically kind of like a bulldozer. They can be very, very destructive and cover a pretty large area. And one thing to note here, some of these strongest winds, an example of which could be a derecho, which we'll talk about in a second, they can be as strong as low-wind tornadoes. It's not uncommon. But one of the defining characteristics is it's going to be a very long area, widespread damage, not quite as narrow as a tornado, but fairly widespread. And we're going to have often many reports of damage throughout the county. There are situations like this where actually my second day working, May 15th of 2018, we had a squall and it came all the way across the Commonwealth. And I think almost everybody had at least one severe thunderstorm warning as that thing came through. Very powerful system, widespread damage reports. All the trees were blowing in the same direction, generally west to east. And so it was a pretty clear-cut straight line wind day. Here we are. I got ahead of myself. Look at that. May 15th, 2018. Again, my second day at the office. You can see all these blue dots here. Those are all our damaging wind reports. Some trees down, some huge branches, everything blowing in the same direction. This is a pretty classic straight line wind event. So again, if we're now looking to do a damage survey, okay, so we get a report of a lot of damage. The Weather Service is going to work with emergency management. We're going to come out to the site. The emergency manager is going to take us around and show us what's happening. If we could have ideally an aerial shot, say through a drone or something like that, provided by emergency management, we're going to be able to look at this and see pretty clearly that this is straight line wind damage. Unidirectional pattern. All the trees are blown over in the same exact direction like a bulldozer. So this is a clear-cut straight line wind damage footprint. All right, that was straight line winds. Now let's transition to downburst winds. These are pretty similar, but they're just a little bit different. Basically what happens is instead of kind of forward propagation and along an entire line, you get a burst of wind. What's happening here is it's going to be a little more centralized area. You get a particularly strong downdraft that's going to drop almost like you're dropping, say, an egg, right, that falls on the ground and then kind of fans out everywhere. Or if you ever dump a bucket of water onto the ground. You can see here on the bottom left-hand side, as this comes down, it's going to hit the ground and then fan out in all directions. And so this is often how we see damage occur through just a localized area that sort of fans out. The thing to note here with these downbursts is these can often be even stronger. Sometimes a localized area of 150 mile-an-hour winds, that's pretty much the equivalent of EF3 tornado. So even though it's not a tornado, it can still be very significant. So if we're, again, looking on high at a drone or doing something like that, what we're going to be looking for is how the trees are falling. In this situation, they kind of fan out. You see, straight line winds are going to all fall in the same direction. This downburst is going to kind of fan out and push in all directions. There's a divergent pattern. And so this is, again, a dead giveaway. Okay, we have a downburst here, fairly strong winds, downburst occurred. We would determine that after coming out looking at this, that, hey, a downburst occurred. We'd be able to estimate the damage based on how much damage is. There's different damage indicators, et cetera, et cetera. We'd be able to determine, okay, a downburst occurred in this particular location. So there's two different types of downbursts. You may have heard these two terms thrown around before. We pretty much just put these in here for information purposes. There's a microburst and a macroburst. And as you can imagine, it's all about the size. A microburst is going to cover an area about 2.5 miles or less. So this is going to be a fairly small, confined area. A macroburst can be a little bit bigger, anything greater than 2.5 miles or greater than or equal to 2.5 miles will be a macroburst. It's really just semantics. It's not super important, but when you hear those terms, that's what we're referring to there. And then I mentioned this a little bit ago, a particular type of straight line wind damage is a derecho, a large scale damaging wind event with rare but very significant damage. This schematic here shows June 29th, 2012. I will never forget. I was just finishing up, I had just finished my freshman year at Ohio State. I was back home at my parents' house just southwest of Columbus, right about here. And I remember looking at weather radar and being able to see this big old bow echo coming across. And man, it was wild and crazy. By definition, a derecho is greater than 250 miles in extent, sort of from end to end. And this certainly was, and it lasts longer than 6 hours. Widespread power outages occurred with this particular event and widespread devastating damage. So it's been a little while since we've had a derecho here in parts of Pennsylvania, but it certainly is a possibility that it can occur. Hopefully we won't have to worry about any of that this particular summer. But again, just something to note. If you ever heard the term derecho, this is what we are talking about. All right, now I probably think it's safe to venture and say that most people are here because of tornadoes. It seems to be a pretty hot button issue, hot button item. People are fascinated by tornadoes. I certainly was. I had a chance to go storm chasing back in 2013 and saw the Moore EF5 tornado as it touched down. It was phenomenal, just breathtaking. Also pretty mortifying, or yeah, horrifying and scary. Man, tornadoes can be pretty powerful things. The thing to note here is it's a super specialized event. You got to have the perfect combination of conditions very close to the ground to produce a tornado. And only about 1 in 10,000 thunderstorms produce a tornado. So it's not a very common thing, but it is certainly something that a lot of people are fascinated by.
And even
so again,
in Pennsylvania, that ratio is, a lot lower in Pennsylvania. It might be, 1 in 50,000 or 1 in 100.
Probably a really good point, right? Especially in spots that aren't as prone. So we're not going to necessarily take, a poll or anything right now. I guess we could implement that at some point, but curious, just for you guys to think to yourselves, how many tornadoes do you think Pennsylvania sees every year? Give you guys a chance to think about that. Is it 5? Is it
chat box up? Throw a number in there.
Yeah, sure, absolutely. If anybody wants to chat in and see what kind of numbers you think, feel free to do so. So I think it's 50. It's 100. Think it's 5, 10. Let's see. 15 tornadoes per year. Not a whole heck of a lot. Now, we all know that there can be some years where there's more than that even on a single day, which we'll talk about here in a little bit. But generally speaking, it's a pretty small and defined area of damage. But one other thing to note, oftentimes we'll get calls from even spotters that'll say, hey, my barn has been obliterated, must be a tornado. It's not really how it works. We look at things like how the barn is manufactured or the strength of the structure. As we mentioned, straight line wind damage or derechos can produce even stronger damage than low-end tornadoes. So degree of damage is something we take into consideration, but it is not a giveaway that a tornado occurred. As I mentioned here, April 2019, record-breaking month. This is a pretty impressive day here, April 14th through 15th, and then again on April 19th. Worked a couple of these events, and you can see a total of 14 tornadoes across many parts of central Pennsylvania. And so even though on average Pennsylvania sees about 15 tornadoes per year, there's certainly situations where we can get more just in a single event. Now, at risk of kind of pushing into an advanced spotter training, I do want to just dive into this a little bit, kind of high level for the folks that are interested in it, give you an idea of kind of how an idealized thunderstorm works. So basically, this is a big cumulonimbus cloud, and we have an overshooting top. Basically, air gets lifted really fast and really high, overshoots the tropopause, and you end up getting this overshooting top, kind of at billows up top. Then you get an anvil that overspreads with some of the stronger storms, and then down towards the surface, you can get a shelf cloud. That often happens out ahead of, say, a squall line or something like that.
Yeah, we saw
a wall cloud lowering. What's that, Mike?
I said we saw a picture of one earlier.
Yes, indeed, we did. saw a picture of the shelf cloud. So here's just a schematic. And for straight line winds, here's what happens: you get rain cooled air at the up in the cloud that then surges down to the surface because it's cold and dense, and then it gets pushed out ahead of the storm. And this is the nature of a straight line wind. So you get, again, air from aloft that's more cold and dense, sinks down to the surface and surges out ahead of the storm. And then you get some of these strong straight line winds. Now, a downburst, it's very similar. It's just a little more localized region. Once again, this is just going to be a little bit colder, denser air, a more focused area. And because it's coming down so strong, it's not just going to get pushed out ahead. It's going to fan out in all directions, and you end up with more widespread and significant damage. And then tornadoes. So this is a pretty unique situation. Basically, what happens is you get air that rises from the surface. Let's see if my schematic can do it. So it rises from the surface. You get some degree of spin in the atmosphere. We call this, the fancy term is vorticity, in essence. And so if you think about it like an ice skater, okay, if you're spinning around, your arms are out, you're spinning all the way around. When you bring your arms in, that allows you to what? That allows you to speed up and go a little more quickly. And so basically what happens is we get spin here within this tornado, and then it stretches out, reaches down to the surface, and then results in the formation of a tornado. So again, we'll do an advanced spotter class at some point, maybe this spring if we have time, but more or less that's what's going on. You get rising motion that's got some degree of spin with it. That spin is stretched, reaches down to the surface and forms a tornado making contact with the ground. Another brief glimpse into Doppler radar. Many of you guys may be familiar with this. I'm not sure your level of knowledge and expertise, but basically what we use to be able to estimate whether a tornado is occurring is pretty much solely Doppler radar. So what happens with a tornado is, because it's this kind of area of low pressure, you get a lot of inflow into the system. A tornado sort of acts like a vacuum. It's not a perfect example or analogy, but acts like a vacuum. So everything kind of gets sucked into the tornado. And what happens is you get convergence. And so when you look for tornado damage, that's really what we're looking for. So as you look at Doppler radar on the right-hand side here, you can see there's your reflectivity pattern. You may be familiar with this, sort of some of the greens and yellows and oranges and reds. And this is a schematic of a supercell, a pretty ideal situation with the hook echo there on the back side. Some of you guys may be familiar with that. But then looking at velocity, we really should update this velocity map with something a little bit more high resolution. But the bottom line here is a couple things. One, that black circle, that's the location of the radar. Okay, so you can see that where the radar is to the west of this particular area that we're going to focus on right here. Now, the thing to note with velocity, when something is moving towards the radar, when the radar surveys that something's moving toward it, it's going to show up as green. And when something's moving away from the radar, it's going to show up that that thing is red. So this broad area right here shows green to red. So the winds here are moving from east to west. It's a little bit kind of an anomalous wind pattern, but that's kind of gives you an idea what's going on. So the winds are moving from basically right to left on your screen. Okay, but down here then, we have two different areas. So to the north here where it's green, it's moving towards the radar, okay? Down here in the bottom, it's red, it's moving away from the radar. These are right next to each other, so that implies rotation, okay? Does that make sense to everybody? Mike, were you gonna say something?
Yeah, I was just gonna say this is probably a storm relative velocity, which is maybe why the normal west to east.
Probably right.
But yeah.
Yeah, you're probably right. But the bottom line here is what we're looking for is red next to green when we're sitting at the radar scan. That's not the only thing we pay attention to, but we look for tightening of these what we call velocity couplets. They give us an indication of, okay, maybe there's some rotation that's tightening, getting stronger, and that could indicate a tornado on the ground. And there you have it. Again, we already talked about this. You guys are velocity experts now, able to sniff out any sort of rotation on radar. So now let's talk about some terms as we're doing tornado spotting. So the first thing I want you guys to store in your mind is wall cloud. This is a rotating, lowering section of a thunderstorm. So often there's not rain associated with this. It's going to be sort of on the southwest side of an ideal, say, supercell if we get anything discrete around here. But the important part is rotation is the key. We need to make sure that this lowering is rotating in order for it to qualify as a wall cloud. But the important thing to note is it's not causing damage at this point. So it can be a precursor for a tornado. We certainly want to know if you're seeing a wall cloud, and in your location, we can then look at radar and kind of keep an eye on it, but it's not causing damage at this point. The next thing we're going to look at is a funnel cloud. So this is sort of the next step. You're going to start to see a fast spinning funnel descending from the thunderstorm cloud, generally in the area of that wall cloud. You might start to see it just kind of surge down a little bit farther. And the importance here is rotation. Rotation has to be occurring for it to be a funnel cloud. Sometimes you can get things that are called scud, where you could just get cloud lowerings. There's no rotation, that's not causing any harm. We don't necessarily want to hear about that, but if there is a rotation, we certainly want to hear about that. And a funnel cloud is a pretty strong indicator that conditions within the storm are right for producing a tornado. So we're starting to gear up now. In Pennsylvania, it's pretty rare that we get funnel clouds. So if we get a funnel cloud, we want to hear about that, because it's probably time for us to start pulling the trigger if we haven't already on issuing a tornado warning. Now, again, funnel cloud's not going to be causing damage. If it is a funnel cloud, you're not going to see any debris kicking up from the surface. There's not going to be any anything happening imminently, but it is probably a precursor for a tornado. So we definitely want to know where that funnel cloud's occurring, which direction you're looking, etc. So again, there's a rotation there. And then finally, we get to the fun part, tornadoes. Rapidly rotating funnel of air in contact with the ground. Now, one little just side note soapbox thing, tornado on the ground is repetitive. By definition, a tornado is on the ground, but just something to note. A tornado, again, if it's a tornado, it's in contact with the ground. The thing to note here as well, generally speaking, if a tornado is not causing damage, it's not yet a tornado. Could be a funnel cloud that looks pretty close to the ground, but if there's not debris kicking up, again, this is all semantics. In Pennsylvania, if we're seeing a funnel cloud, we sure as heck better be pulling the trigger, because generally we don't get many tornadoes around here. But again, we want to make sure that it's rotating, make sure it's in contact with the ground to officially call it a tornado. Let's see here. Okay, a couple videos here, just some eye candy as we continue moving things along. This house on the top left looks like a pretty breezy day. You know, not a whole heck of a lot to worry about at the moment. And all these things are going to change pretty quickly here, very shortly. There's some lightning. You start to see some debris kicking up, and quickly things are darkening. Yikes. And there goes the roof. Yikes. Not good at all. In the interest of time, we'll go ahead and skip this one. Similar tornado damage video here, but pretty interesting stuff. Just, again, some eye candy. Now I'm going to toss it over to Mike for debunking some common tornado myths.
You know, I've gone out on many storm damage surveys. The reason we go and do storm damage surveys is for science purposes. Researchers and our own warning forecasters, we want to know what made the damage. You know, was it straight line winds? Was it a downburst? Was it a tornado? And, you know, if there was hail along with it, you know, we want to talk to people and find out what they went through, what time it occurred, how strong they think the winds were. Did they have observation equipment maybe in their backyard? They just have a hobby setup. But, you know, some of the things that we hear sometimes when there'll be a news report of, well, there was damage and, well, the trees were all crisscrossed, then it must be, you know, tornado damage. Doesn't have to be. Generally, tornadoes do have that convergent signature where things are being sucked into a center point as the tornado moves on through. So they can be crisscrossing there, stuff flying all over the place. But there are a lot of things that can change the wind direction locally. Think about the leaves blowing around on your back porch. You know, they'll swirl around because there's some faster wind going by the side of the house than you know, being able to come over the top of the house. And the things just, the trees themselves may have weak points. You know, downburst can also cause trees to lay in different directions. You know, the roaring sound is a tornado. No, the roaring sound is from the wind, period. If, you know, that straight line wind is 100 miles an hour, it's going to sound 100 miles an hour. And that's what a tornado sounds like. You know, that if there's damage, there's a tornado, also a myth. No, not every time there's, you know, trees down, roof comes off a house or a barn, not all the time is that a tornado. That's why we like to go out and, you know, speak with people and, you know, map out things, take photos if we can. And John had mentioned before having a drone that the local authorities might be able to bring along with them. That would be really get to those telltale signs for us. So here's the tornado damage I just mentioned. Things converge during a tornado. I don't know if you noticed that last video, or the next to last video that we saw, the one of the house there. Let's see if that one there that's playing right now. Note how the wind is changing direction as the tornado itself is coming in from the left-hand side, coming from stage left. But the wind starts turning directions, and the wind is generally now being, sucked into the tornado. So, a picture like we would have here on the upper right-hand side there is it really converges into a spot. It's a wonderful fingerprint. And here's damage that you can see in a cornfield. Trees are our most common thing to see tornado damage in Pennsylvania, because we have a lot of cornfields, we have a lot of trees, but it's easier to see in the trees, and people don't generally notice that the corn blew over or that it was flattened. So, one of the things that we do look for when there's tornado damage is, things are being sucked into a center point. Again, I just said, not all the time when things are crisscrossing is it going to be a tornado, but that is, one of the keys that we'll look for. There's tornado damage, storm that came through in October 2018. The way, if you squint at it real hard, like me with my bad eyesight, down here in the bottom part of the picture, you can see the root balls of the trees as they were torn up, and they're all pointing generally toward the top of the picture. But you can see some of these guys over here, they're pointing toward the top, but more to the right. These ones over here are pointing to the top, but more to the left. And yes, these get even tighter and tighter, more to the left, more to the left. And you can actually see there's a little bit of a twist. So something went through that field there, came up this hill, and was even, pulling trees in from this direction over, from right to left across the screen. So that's a really good signal that the thing that made that damage was a tornado. You can tell it wasn't a downburst because the root balls were here and the tops of the trees were here. If this was a downburst and the winds were coming from the top of the screen out and down, the trees would be facing the opposite direction. So, if you've got eyes like me, sometimes you have to squint at things. But here's another video. I'm gonna just go through this. I guess it's the central circulation point. You can see at the bottom of the tornado there, where it's hitting the ground. You can see things circulating around. But it's an awe-inspiring sight, and to know that it's doing damage as it's going along. Quite terrifying. So we estimate the speed of a tornado only after it's happened. There's no way we can tell for certain before it, or as it's happening, or certainly before it happens. As it's happening, and we're looking on the radar, and we're gathering all the information that we can, not only from spotters but from the radar information, we can estimate when it's a really, really bad tornado. Winds of 120 plus. If it's anything less than that, which is most tornadoes in Pennsylvania, we still have to go out and do a damage survey to figure out how bad the winds were. Well, that's because we have people who made that groundwork for us. Ted Fujita was a professor a long time at the University of Chicago. The enhanced Fujita scale, he came up with a thing we all call the Fujita scale. It was how fast the winds were blowing, for that tornado. It was actually, his work was actually based on the damage that occurred to buildings in Hiroshima and Nagasaki. And how fast the burst of air was coming from the nuclear blast. That morphed into a interest in aviation, and then to severe winds. So he made this scale. We called it the Fujita scale, but a lot of that was subjective. Then it took science, and I think where was it, John? Was it Texas Tech? Texas A&M. They had
I think it was Texas Tech. Yep.
it was, that they actually put things to the test at Texas Tech. They took things like 2x4s and blew them through stuff. They went out and they went through a long record of all the things that the Weather Service had gone out and did storm damage surveys before on. And they came up with a more subjective scale where we can look at a bunch of things. John called them damage indicators before. A tree of one type, a pine tree is one damage indicator, where an oak tree, because it'll break at a different speed of wind, it's a different damage indicator. A residential home, stick-built home, is a different damage indicator than a school or a church is, and how those things are built, how they're reinforced. And from that, we can now go through almost, I guess, a spreadsheet kind of thing. Check the boxes. Did this happen? Did that happen? How many shingles were off the roof? And we come up with a better estimate on the wind speeds now with this enhanced Fujita scale. As you can see, that most of the tornadoes in Pennsylvania are EF1 or EF0. It's kind of rare that we get to 2s, very rare that we get to 3s, and extremely rare for EF4 and EF5 tornadoes. I think the last biggest one was that the EF2s that occurred in October. John, do you remember?
Yeah, I think the EF2, yep, that one that we just showed up in Lycoming County.
Was there a 3 in Scranton area?
Yep, there was Wilkes-Barre. Yep, Wilkes-Barre neck of the woods. Yep, there was an EF3 that particular day as well.
I cannot remember the last EF4. I'm trying to think if the last EF4 was with the May 1998 and June 1998 tornadoes. Oh, by the way, May 31st, 1998 and June 2nd, 1998, 2 of the busiest tornado days in the history of Pennsylvania. That was my, let's see, maybe 5th or 6th day here at the State College Weather Office. And I was sitting there drinking a lot of Coca-Cola and Pepsi, trying to keep myself going, running the radar, making warnings. So, the total number of counties, or tornadoes by county through 2015, we'd probably have updated information like this. I believe we would have new stuff. But you can kind of see a lot of the tornadoes in Pennsylvania happen out in the west. Then also your population tends to thin out as you go through the central mountains, and then builds again, especially over the southeastern part of the state. So sometimes the reporting of tornadoes, the occurrence of tornadoes, is due to people seeing them and having something happen to them. But some of it is just the climatology of it. The number of tornadoes in western Pennsylvania is really because of the weather patterns and how they set up, is that a lot of times there'll be damaging storms come in from the west, but by the time they get time of day that they get to central Pennsylvania, they are weakening. Whereas in the southeast, sometimes it'll get much more moist, and that's the fuel for the thunderstorms, get much more moist down there and in the southeastern part of the state than it would here in the central mountains. So maybe that's where a lot of their higher numbers come from, is tornadoes by county. So I guess I'll let John talk. You know what, John, can we take the break here?
Yeah, that sounds good.
Okay, yeah. I mean, it's been about an hour now.
Yep.
Sure. Some of you may want to, get up and, get a drink or something.
Let's take about a 5-minute break. We'll be back here about 7:10 or 7:11, and then we'll resume with the second. Well, I guess the third of the next third of the presentation. We'll try to get you out of here by 8 o'clock at the latest. We'll talk about flooding and winter time as well. So 5-minute break. We'll reconvene here in just a little bit. What do you say? Shall we resume, Mike?
I'm ready.
Okay, 7:10. We'll go ahead and get started. Hopefully you guys are wandering your way back now. Let's just recap this section now with what you should report. So if we get severe weather here in the next couple of weeks, or certainly over the course of the summer, here's what we want to know about. We want to know winds in excess of 58 miles an hour. We want measured or estimated. If you have a Kestrel or something like that and can actually measure the wind speed, that'd be great. If it's just an estimate, let us know that as well. We also want to know sub-severe thunderstorm winds. So do you have something that's in excess of 40 miles an hour? Could it be a strengthening storm? One of the things that I like to communicate when it comes to this is we want to know what's happening with the storms right now, because it helps us, even if it doesn't give you any added lead time, it helps us downstream. So if there's a storm that's in your county that we have a severe thunderstorm warning out for, but it's only producing 40-mile-an-hour winds, we want to know that so we don't overwarn people downstream. Similarly, if there's a storm that we don't have a warning on that's strengthening, that's going through your neck of the woods, even if it doesn't produce damage or doesn't have anything like that, we want to know what's going on, because again, you're the ground truth. You're telling us you're giving us eyes on the storm, and that can really help us. We also want to know any damage that's been produced by that particular storm. Are there snapped or uprooted trees? Are there large limbs down? The small limbs we don't really care that much about, but certainly large limbs. And then roof damage, or their barns or buildings destroyed. What's the extent of damage? It's really important that we know, if you say we got trees down, how many? We're talking 1, are we talking 50? That makes a big difference as we're making warning decisions. So as much detail as you can provide, as well as your location and the time as well. Those things would be really helpful for us along the way. See if I can just keep on clicking through here. Oops, sorry about that. So tornadic activity, as we talked about, we want to know about all these things: wall clouds, funnel clouds, tornado. The important part, again, is rotation. We want to make sure that you're communicating with us rotation. We don't just want low-hanging clouds that look really ominous, that aren't spinning at all, because that's just going to make us make a bad decision. But please let us know, and any information you can provide about the location. Where are you? What direction are you looking? Where's the storm moving? What intersections are around you? As much detail as possible would be really helpful for us. Now, what should you report as far as hail is concerned? Any hail is important to us. As we said, if there's hail, we probably want to have a special weather statement on that thing. But it'll be severe if it gets to 1 inch or greater. Just a word of caution: do not call us and say, I got marble-sized hail outside my house. What does that even mean, huh? Marbles can be all kinds of different shapes and sizes. It's a common misconception. Just try to use coins. That's really helpful.
Sports, and money. Food, sports, and money. That's all meteorologists care about.
Exactly right. So please, as you do that, what's even more helpful for us is you're reporting hail. If you can send us a picture with the hail next to a common object, that's helpful. If you can put it next to a ruler, the more detail we can have, the better we're going to be able to trust you. We want to trust you. Hear us out here. We want to trust what you're saying, but some people can ruin it for us, and we don't want to get burned by taking a report that ends up being false. So if you can help us, send us a picture, send us some identifying characteristic that we can compare that hail size to. That'll be really, really helpful for us along the way. Here's a nice aerial shot of a big old hail swath in Colorado, taken from an airplane. Another picture there. That's one of those cases of a lot of probably small hail. Again, we care about that. We're not going to issue a warning for something like that, but hail can dump pretty good. Not usually around here, but certainly out in the high plains. All righty, so that was severe weather. Now let's transition into flooding, and my main man, Mike, is going to take it over.
Thanks, John. Flooding is also severe weather. Flooding kills more people in the United States every year than all other forms of weather combined. Flooding can be in many different forms. The most common that we'll think about is river flooding, when there's a great deal of rainfall over a long period of time. Maybe comes from the tropical storm or a hurricane coming inland. That tremendous amount of rainfall over a long period of time makes all the larger rivers go high, and they will affect the most amount of people, and they will probably last much longer than just from one thunderstorm. The streams and the waterways all around us really aren't gauged You know, the larger rivers and streams, they do have automatic reporting rain gauges, and flood gauges on them, and they will tell us. You know, we will get that information either through the phone lines or through computer. It will tell us every couple of minutes just how high the water is, and we can monitor those things. And we'll talk with the folks here at the River Forecast Center that are right across the hallway from us. We can talk to them, and they're the experts on the river flooding and how bad it can be, when it will happen. The river forecast is driven by a number of things, and mainly it's the forecasted rainfall, but also how wet has it been? Is there snow that will melt along with it? In the spring, this is a trouble for us. When the spring rains come and they're melting all the snow at the same time, that snow then becomes water and liquid water, and runs off into the streams as well. If it's too cold, then maybe the water doesn't run off as fast because the ground is frozen. It may run off faster. There's a lot of things that go into it. I think flash flooding is the most dangerous kind of flooding. It happens very quickly. In general, it's less than 6 hours from the onset of the rainfall. Flash flooding is the most deadly kind of flooding because it happens without people realizing that it is going to happen. One of the reasons we set off the emergency alert system for two things in Pennsylvania. We set it off, the Weather Service product set it off for two things: a tornado warning and a flash flood warning, because both are so deadly and people need to know about them immediately. Those rapid rises on the streams and creeks are because of intense rainfall produced by slow-moving thunderstorms. Sometimes there'll be more than one thunderstorm, repeated thunderstorms over the same area, and they can also happen when dams break. We haven't had a dam break here for a while, but our dams are getting older. A lot of our dams were built 50 to 100 years before, and they need upkeep. There's money that has to be put into them to keep them safe. Now, these streams and creeks respond, in just a few minutes to a few hours after the heavy rain event, but it's the danger to life and in this case also property, because it could wash your stuff away. The more general flooding that we'll talk about is aerial flooding. It happens a little bit slower. Maybe it's less intense rainfall, but a lot of it still comes from thunderstorms. And it can happen from repeated rainfall over the past few hours or past few days, depending on the time of year that we're in, and just the weather pattern that we're in. These are situations where streams and creeks respond several hours after the rain has started, and they're more of a threat to property than life because you can see it coming a little bit clearer than the flash flooding, which happens so much more rapidly. When you report flooding to us, we'd like to know, well, what is happening due to the flooding? Have they had to close a road because of it? That's usually one of the first signs that things are getting pretty bad, is that a road nearby you has gotten underwater to the point where the authorities think you shouldn't be driving through it. You should never drive through flowing water, never. Are the homes getting flooded? Is water coming into the lower levels of the homes, not just because of seepage? I lived in houses that have had, seepage into their basement, so the basement gets flooded for reasons that are not, flooding per se that will cause damage to other people's properties. But what is the cause too? Was it because you just had a big thunderstorm, or are things backing up because of maybe an ice jam downstream of you in the wintertime? When did it begin? How high is the water? Relate it to me. Tell me it's it's up to my porch. It was only up to maybe the front of my yard earlier. So how much of a change is that? I'd ask you, and you'd say, well, that's probably 6 or 7 feet higher now. Just don't go out and measure. Just approximate for me. Are there any evacuations around? Have they started to move people out of homes? You know, sadly, there's a lot of mobile home parks that are built in low-lying areas, and those are one of the first places they're usually pulling people from. Is you know, they're telling people to get out of their homes and just move up to higher ground. So that's the safest place to be, is higher ground. Are there cars that have been stranded, or you know, people have to take a boat out to get somebody and bring them to safety. You know, so heavy rainfall too. Don't just report whenever there is flooding going on, but we'd like to get a jump on it. We'd like to get the word out there before the flooding would start happening. So we'd like to hear about heavy rainfall rates. Now, rainfall rate is how fast it's falling, how much is falling in an hour. It's not the accumulation. If you tell me I've got 2 inches of rain since midnight, okay, you've had 2 inches of rain. But if you tell me I'm getting an inch per hour, I've gotten 1 inch over the last hour, and it's gotten more intense recently, then I can understand that's a rain rate. But also report to us after a storm has ended, you know, if the rain has gone, and you know, you can look around and say, oh, hey, it's all over. We'd like to know how much it was, because usually we'll put together a summary of how much rain has fallen, and that's a curiosity to many folks, and it's also good for the record. I think let's just skip on through that. I think we'll let John talk about winter.
Sounds good, Joel. Just bouncing out so I don't steal the show from Mike as he does his sections. So we noted here, although it's almost summertime, although the weather hasn't quite cooperated, winter weather reporting is also a part of the Skywarn program. And for those of you that may be joining us from the mountains of higher elevations, even this weekend, you might get a chance to test out some of these skills. So basically what we're going to mainly talk about is the proper way to measure snowfall. It's kind of complicated, it's kind of convoluted, but hey, that's the government for you. We just want to make sure everybody's on the same page here, and we can hopefully do a pretty decent job of this. So let me see. Okay, yep. So when we issue winter weather products, so winter storm warnings, winter storm watches, or winter weather advisories, we are issuing those based on predetermined criteria. And so when we issue a winter storm warning, over a 12-hour period, we are expecting the following totals. For much of central Pennsylvania, we're expecting 6 inches in 12 hours. Farther south and east in the lower Susquehanna Valley region, we're only expecting 5 inches over a 12-hour, period. 24-hour wise, we're bumping up a little bit more, 8 inches across most of the area, with 7 inches elsewhere. One thing to note is there is variability based on location. You probably can know this intuitively, but say an inch of snow in Atlanta, Georgia is going to cause a lot more impact than an inch of snow in State College, Pennsylvania. So we have different thresholds, and this is kind of what we're using here. So in your neck of the woods, just keep that in mind. If we issue a winter storm warning, we're expecting a given amount of snow over a set amount of time, 12 or 24-hour criteria. Winter weather advisory, as I mentioned, we're just as confident, we're just forecasting lower totals. So let's go back here. 12-hour winter storm warning here in Center County, 6 inches, whereas a winter weather advisory, we're only expecting 3 inches. And so again, it's just different thresholds for going through this. So now, snow measurements, not an exact science, as we said, but we want to talk about a couple things. Mike did mention rainfall rate versus rainfall total. The same thing applies for snow. So we need to be clear on the difference between snow rates and snow accumulation. Snowfall rates are a short-term rate of accumulation. Okay, so in essence, it could be dumping buckets, as we say. It could be puking snow. That's a very technical phrase that we use sometimes for when it's just snowing like crazy. It's snowing at a rate of 1 inch in an hour. Okay, so that can last for a short amount of time, and it can be dumping buckets of snow. It's not going to accumulate a full inch, but it's going to be coming down really hard. That's the snowfall rate versus the snowfall accumulation. That's how much snow is falling from a storm. So in total, that's how much is falling. Say I've gotten 2 inches over a 3-hour period. A snowfall accumulation is 2 inches. In that 3 inches in that 3 hours of snow, maybe there was a period of 1 inch per hour snowfall rate. And we want to know the difference between those two things. Those can have some really big and different impacts. So what do you need to measure snow? First, a snowboard. We usually recommend a 2 foot by 2 foot board. preferably painted white. Now, let's think about this. Why do you think we would want the snowboard to be painted white? Well, it has something to do with the absorption of sunlight. We don't want the snow to melt, so we make sure that the board is white to reduce the impacts of heating that the sun would cause to cause melting. So again, we want it to be white. We don't want it to be anything else. We don't want it to be black, certainly, because that's going to skew our snowfall amounts, but make sure it's white. Also want to get a ruler. Ideally, it's going to be divided into tenths because that's how we record our snowfall. We don't use sixteenths, we use tenths. You can do the conversion in your head or whatever, it'll be fine. And then also some flags would be helpful, especially in areas that get a lot of snow. I want to be able to find your board after you get a decent amount of snow. Certainly wasn't the case this winter, but say we get 6 or 7 inches, that's what we really want. So now as far as the method is concerned, we are going to be kind of talking about how we do this. First, we want to find a representative location before the storm. We don't want it to be near a building because that's going to probably be susceptible to, say, snow drifting. We don't want it to be near trees and bushes that could shelter the board. And we definitely want to encourage, if you're really into this, multiple locations so we can kind of take an average of all those different sites. So that's first. Find a location that's representative before the storm happens. Then we want you to place your snowboard and your flag. The important part of having the snowboard is that it provides a hard surface for your ruler to go down in. If you're using it in the grass, there could be some variability that could skew your snowfall measurements by as much as an inch or even 2 potentially. But making sure we want to use that board, and again, we want it to be white so it'll lessen the melting impacts. And then finally, we want to measure the snow. So the official policy for the Weather Service, bear with me here, is to measure once every 6 hours. Okay, so for a storm that's less than 6 hours, this is totally irrelevant. But say we get snow that's over the course of an entire day. So what you're going to do once the snow starts, okay, you're going to denote that. Or you could even say, so say you just set that I'm going to measure at 8 a.m. and 2 p.m. and 8 p.m. Okay, so every 6 hours. So say the snow starts at 10 a.m. Okay, at 2 p.m. go out and measure the thing. That's your first 6 hourly total. Okay, you're going to clear off your board. Okay, start fresh. And I
would stick in there, John. I would, if I may jump in.
Yeah.
Only clear half the board. Leave half the board so that it, you get an idea of how much, would be building up, and also seeing the compacting and things like that. But I would say maybe only wipe half the board.
Boom. That's perfect. I clearly haven't been around for many snowstorms to be able to really be an expert at this. So Mike's definitely the guy. But yeah, so clear off half the board at 2 p.m. Okay, and then go back out at 8 p.m. and measure that half of the board that you'd cleared off. That's your second 6 hourly total. The storm total snow would be a sum of your first 6 hourly and your second 6 hourly. You're going to continue that for as long as you need to. So that's going to be your snowfall accumulation. Okay, does that make sense to everybody? The reason why we don't want to measure more frequently or less frequently is because there's going to be different amounts of compaction. If you're measuring every hour and then clearing off, you're not going to get as much compaction. If you're measuring every 12 hours, you're going to compact too much. And so we want to all be on the same page again. 6 hours is the adopted norm for measuring snowfall. Okay. Now, one other thing that we like to measure is called snow depth. Okay. Snow depth is the snow on the ground. It's not the sum of your 6 hourly measurements. And this can sometimes be a combination of multiple snowstorms. So like this guy doing in our picture, like this guy's doing in our picture, basically you're just going to go measure a spot where there's been snow on the ground for a little while. That doesn't necessarily have to be on your snowboard. It can be, as Mike said, if you keep half of your snowboard not cleared off. Basically, it's just going to be how much snow is on the ground, and that's gonna be really helpful for our river forecasts. If we have an idea how much snow is on the ground at your particular location, that gives the river forecasters an idea how much liquid could be melting into the rivers, could enhance flooding, et cetera, et cetera. So again, here is what Mike is mentioning. Consider wiping only a portion of your snowboard each 6 hours, and the undisturbed portion could be used as your snow depth. There's multiple ways to do this, but we just want to make sure that everybody's sort of on the same page. Snowfall accumulation going to be measured every 6 hours. Snow depth is just going to be wherever and sort of whenever as well. Dang it. All right, this is maybe my favorite part of the presentation, so sit back, relax, and enjoy the ride. This is a time lapse of puking snow, as we have called it. Wintertime, rapid accumulations, pure dendrites, as we like to say. incredible. I'm not a big winter fan, but this is a pretty mesmerizing loop. So let's play it through one more time. We're coming to the end here, folks. So thanks for bearing with us. But man, this just makes me think of some of my coworkers. Maybe not so much Mike, but some other coworkers. Back when I was growing up, we used to get all these big snowstorms. We don't get them anymore. Hopefully, at some point, we'll get some big snowstorms at some point. All right, so that's snow. Now let's talk about sleet and freezing rain. Sleet, balls of ice that bounce when they fall. Some people also may experience what's called grapple. We don't really talk about that right now, but those are kind of like dip and dot type things that fall in the cold season. Sleet, balls of ice are going to fall, and they're going to accumulate. Not quite as dangerous as its pure freezing rain. So freezing rain falls as liquid, okay, and then falls onto a surface that is below freezing and freezes. So that's when you get a sheet of ice. Freezing rain is much more dangerous than sleet, but we want to know about both of those. Are you getting sleet at your location? How much is accumulated? How much freezing rain do you have? And you're going to measure the accumulation of ice generally to the nearest tenth of an inch. Ice storm warning criteria, basically if we get a quarter of an inch or greater across much of the southern part, or the southern 2/3 or so of our area, we're going to issue an ice storm warning. Need a ½ inch or greater across the north. So yeah, that's an overview of the ice consideration. All right, so what should you report? Again, hone in here. If you guys can, let's touch base here, and this is going to be Mike D taking it away for us now.
Thanks, Sean. What should you report when it comes to winter weather? Well, during the storm, report whenever your accumulations reach, certain thresholds, like, 3 inches. If you've got 3 inches of new snow, if you got 6 inches of new snow, give me a yell. Storm total snowfall, when it's all over, as near as you can tell, or look at the radar and tell, it looks like, the storm is over in my location. Give us a total as soon as you can after the storm ends. We love to see pictures, post it on social media, email it to CTP Storm Reports. We'd love to have that information in a visual form too, especially if you could put the ruler in there and maybe have something to compare it to at least. Then snowfall rates, if you have been getting an inch per hour rates, that's pretty heavy snow. That's extremely heavy snow. Let us know that. If the rate is 1 inch or more per hour, let us know. If the visibility goes down to less than 1/4 of a mile, let us know that, because again, that is pretty much the intensity of the snow. How heavy that snow is at the time is what cuts down the visibility during snowfall. Bigger flakes also cut down the visibility a whole lot more efficiently than smaller flakes do. So, and snow depth. That total of snow on the ground, if you started with 6 inches of snow and you got another 5, tell me both those numbers. Just the more information I have, the better it is. If you get any sleet, and especially if it's any accumulation of sleet, we'd like to know about that too. The road crews that are out plowing the roads, they have a tougher time with sleet, because as people drive on top of sleet, it compacts into ice. It's no longer a separated little ice balls anymore, but it squishes down right into more of a sheet of ice, and it can be dangerous, just as dangerous as John said, its cousin, freezing rain. And if you get any freezing rain, let us know. After a little while, you can tell us how much has started to accumulate on the branches. And if you're measuring around the whole branch, remember how big that branch is in the first place. And then, if you're looking, from side to side, across the branch, not all the way around in the circumference of the branch, from side to side, if you can see that there's a 1/4 of an inch or more of ice, we certainly want to hear about that. How to report? We talked about all the different things to report. Well, let's talk about how. I love this first one, the phone. I love it because I can engage you in a conversation. I can ask you specific questions that can clear up, any questions that we may have about a report. If you send me an email saying something, well, I can take that email and I'll put it in context with all the other reports that we've gotten, see if that makes sense to me. But if you call me and you tell me and you send me a picture, that would be great. On social media, you can post a picture or just give us a shout real quickly.
Let me just hop in here real quick, Mike, if you don't mind. Yeah. If you guys can go to the handout section of your webinar, and you can access the spotter reporting guidelines.pdf file. If you go ahead and look at that and pull that up as Mike's talking through this, that'll help you. The number that you can call is listed along with all this information. So if you could just pull that up as Mike's talking through, I think that would be helpful for your guys' following everything that he's talking about. Thanks, Mike.
Oh, thanks, John. I forgot to mention that. So yes, remember to include your location and the time. So many times we'll just get a report from somebody and they'll say, oh, I got 6 inches at my house. I don't know where your house is. Just give me a town name or, Southern Clearfield County, something like that. Give me a little bit of more information than at my house or, as I was driving home from work, etc. So you can report in a few other ways. On our website, we do have a form that you can fill out and send in through the amateur radio links. We can have a couple of great guys here, local volunteers, Greg and Carmine. They'll be in here, and if you know how to work the amateur radio, which I do not, get through to them, and they'll give your reports directly to us because they're sitting right next to us when we're doing this. And of course, ctp.stormreports@noaa.gov is the email we want you to use for severe weather reporting. If you have just general questions about the web page, there's a different email for that. It's down in the left-hand corner of all the web pages. But if you want to send us an email about a severe weather report, send that to ctp.stormreports@noaa.gov. The CTP is our local office's handle. It stands for Central Pennsylvania. I think not a lot of times do we actually go into that, but CTP is our office's handle. It's Central Pennsylvania is kind of what it stands for. So, let us know you sent something. We may not see it right away. Again, pick up the phone, give me a call if it's something very immediate. If you see flash flooding happening, if you see a car floating down the road, call. Don't try and do something over social media. We may not see it right away. The phone is ringing, we're picking it up. So I'll let John say something about how to sign up.
All right, quick and painless, we promise, like our friends here, Three Musketeers. So basically this is, what's that?
That's the Three Stooges, man.
Oh, what am I? I'm aging myself, huh? Jeez, I was like, that doesn't sound right, does it? Okay, Three Stooges. I knew that, but I definitely butchered that one. And here we are. Sorry about that, y'all. All right, so signing up. This is the important part. This is the way that we basically make your time worthwhile tonight. I have, if you haven't already done so, but it should say what you're going to need to do, ... I'll be sending out an email probably actually tonight. I'm going in for a midnight shift tonight. There's going to be a link to a Google form there. And I want you to fill that out with your information as soon as you can. If you're already a spotter, that's fine. Go ahead and fill out the form anyway and indicate that you are already a spotter. If you already know your spotter number from when you got it before, that's totally fine. There's no box at the top to check. We'll just go ahead and send you a new card regardless. The email address is important. We haven't been doing our newsletter for a little while now, but it is helpful that we can communicate with you just throughout the year. Phone number in particular and address are very, very important as well. And so make sure to include those. And then one other thing to note is a media interview. If that's something you're interested in doing, great. We don't do this super often, but if there's a situation where we're out doing a damage survey and media wants to talk to kind of, the eyes on the ground, we could certainly communicate with you about that. So again, look out for an email from me probably tonight, if not, certainly by tomorrow, and you'll be able to sign up. And then after you fill out your forms, give me a little bit of time just in the interest of, keeping track of things, but probably within the next week or two, I will send you an email with your spotter ID number and a card that you can print out to write down your ID number. In the meantime, you don't need to have an ID number to call us and communicate with us. Just tell us you're a trained spotter using that number. It'll be totally fine. We trust you. but I will be getting you that number here in just a little bit. So again, to contact us, there's the spotter line, 800-697-0010. Please don't share this with anybody. The idea is that that can be specifically for the trained spotters. Our public line is also there as well, if that's the one that you can share with anybody. The internet, we have multiple means there. Facebook and Twitter, please do like us on Facebook and follow us on Twitter. We really do take a lot of pride in communicating accurate and relevant information to people. Probably going to be posting about record cold temperatures on Saturday here coming up, which isn't super fun, but it's at least relevant and topical given the weather conditions. And then shoot us an email as well at ctp.stormreports if you need anything. So, man, it's been fun. We've appreciated being here with you today. Here's the amateur radio frequencies. That's also attached in the handout, so feel free to grab those. Make sure, again, you print off the spotter reporting guideline sheet. That's going to be super helpful. Just another reminder, any information you provide to us will be kept confidential. We're not going to share that with anybody, so rest easy knowing that that is the case. And with that, I think we will go ahead and take any questions. I'm just going to look through and see here what some folks have communicated. Let's see, Burke, athletic trainer, rely on our forecasts and warnings through Twitter to help have an understanding of the weather. Very glad that stuff's been helpful for you. Arlen, I see you had the wrong start time in your head. So sorry about that. That's a real bummer. Tell you what, this is our last spotter talk of the spring. I will, I'll make note and I will send you an email of the recording. Just go ahead and watch that, and then we trust you. Somebody's asking about advanced spotter training. Scott, you asked about that. It's been something we've been talking about for a little while. We'd love to make it happen. I would guess if it happens, it'll be sort of a late May type of a thing. And if we do that, we will broadcast far and wide. It'll be on social media. It'll be on Facebook and Twitter. Probably be on our website on the weather.gov/ctp/spotter talks. So just keep an eye out. It'll be hard for you to miss it. And if the end of May comes along, then shoot us an email and let us know, and hopefully we can get something going. Another question here, how do we let you know that the snow rate is greater than 1 inch an hour when we only measure every 6 hours? So you can measure more frequently than that, but we just ask that you don't report a snowfall total in that amount of time, if that makes sense. So say in 15 minutes, right, you get half an inch of snow. You can communicate that to us and say, hey, this is the rate I have. We just don't want to know that you've said, hey, I have X amount. Or more particularly, we don't want you to clear off your snowboard until that 6 hours has passed. That's probably the more succinct way of saying it. Mike, is that a reasonable way to answer?
Absolutely.
Okay. Yep.
You can give us as much information as you want. It's
sure.
The more information we have, like I said, the more information we have, the better it is.
Yep. Do you need our coordinates for the Google form? Can we give you 2, work and home? Yes, there is a way that could happen. I tell you what, Ryan, if you would, I don't know that the form has a place for 2 different addresses. Go ahead and just fill out the form twice if you would, and indicate one being home and one being work, and then I'll go in and make sure the database reflects that properly. And obviously when you call, we'll just want you to indicate whether you're at work or at home. But that'll be totally fine. Let's see. I think that's it. Any other questions here? Go ahead and type them in. I think this worked out fairly well. Not seeing any come in. So just one closing thought. As Mike mentioned early on, this is a new thing for us, this virtual Skywarn talk capability. I think we're coming around to it. We like it. We like the ability to communicate with a lot of people across a pretty diverse area. But in the survey or the form that I'm going to send out tonight, there's an opportunity for feedback. Please provide feedback as you see fit. If you liked what you saw, great. Let us know that. If you hated what you saw, do it. communicate it. Be a little bit nice if you could. Constructive criticism and feedback would be very helpful for us. We want to do this well, and we do think it's been helpful. Being able to just do it from the comfort of our homes is a pretty nice perk. But again, please take some time, fill out some feedback, let us know how we can make things better. If you want to know about the advanced spotter talk or you want to participate in that, also let us know that. That might give us a nice kick in the pants to say, okay, we should actually make this happen. It's something we've talked about for a little while, but just haven't quite had time to make that happen yet. But yeah, if you have any questions at all, don't hesitate to reach out to Mike and I. Mike, can you go back to the very first screen and just put our emails up?
Yep, I see. Do it the easiest way I know to do it.
From beginning, nice. So there are emails. I think I can speak on behalf of Mike and say we're both willing to answer your questions. We might take a little bit because we don't work 24/7, 365, but we'll do the best we can to get back with you. Thanks for spending some time with us tonight. We appreciate you taking the time out of your evening to learn. And just want to reiterate as well, this is really helpful for us. Mike and I really enjoy our jobs. We have a blast doing what we do. We're really passionate about the weather. And we can't do our jobs as effectively without your help. So thank you for being a part of what we do. We want to encourage and fan the flame of your excitement about weather as well. We know not everybody has the opportunity to be a meteorologist, even though many people dreamed about it at one time. So again, thanks for spending time with us tonight. We really appreciate you, and please do stay in touch. We'd love to continue to develop the relationship with you guys, and we hope you all stay safe and healthy in the midst of these unprecedented times.
Please do, please do. Hey, Roger, I see your question there. Do we always monitor Skywarn amateur radio frequencies or only during severe weather events? It really is only during severe weather events. We only have a couple of people in the office who have their ham radio licenses. While the equipment is always here, the volunteers who are here most of the time during those events, Greg and Carmine, they're not here except during those times. You're welcome, Jacob.
I see something else from Brandon in here. I have research grade equipment in my yard to record temp and precip. Is there a way to share that if interested? Brandon, would you send me an email? You can get on our Citizen Weather Observation Program site and figure out a way to upload that. I'm not particularly familiar, but there's some resources out there. So please shoot me an email and we can hook you up with that. All right, everybody. Well, I think that's good. If you have any additional questions, please let us know. But again, thanks so much for coming tonight. On behalf of Mike and everybody at the Weather Service and State College, we wish you all the best, and hopefully we'll talk to you soon.
Good night, folks.
Take care.